Hey there, I'm SourceMic and welcome to part 8 of the Java series where we talk about complex data structures. So as usual, I've got my website open and think of this as a cheat sheet. You can always come back to this page and just remember how the data structures work. So go ahead and click the link below this video, bookmark the page if you haven't already, and while you're down there, hit the subscribe button for this YouTube channel if you haven't already. So again, this is part 8 of the series. I've already done a bunch of these videos and I've already went over array lists in one of the previous videos, and these data structures are basically going to have the same syntax as array list. It's almost going to be the same thing, but the difference is going to be, honestly, the underlying data structures and the way these data structures work. So we're going to go over that, but I'm going to go over them not in too great detail. I already have a data structure video for C++, so go ahead and click the link below this video for that video. It really goes in depth of data structures, why you would need them, and how to use them. I'm just going to briefly mention them in this video. I am going to talk about them, but not as in depth. So complex data structures, the reason you would use them is because they help you solve tasks better. Like this scenario I would compare it to is, let's say you want to build a house. There are different materials that you need for the materials for building a house. Like there's wood, there's bricks, there's cement, there's, I don't know how to build houses, but people who do know how to build houses have a bunch of tools available to them. That's what makes them good. Just like that, in programming, we have data structures that hold our data, and we can access the data in different ways depending on those data structures. Now, array lists are really basic. Arrays are basic. They're just index-based lists like row in Excel, which is really not the best all the time, and we could do a lot better depending on the situation. Learning these data structures well will help you learn how to think in a different way. Like, try to build a house and not know about bricks. That's just like, maybe you don't need bricks to solve the problem, but it would certainly help you with the design, and you could make more complex things if you did know about bricks. Data structures are the same way. Once you know about data structures, especially in algorithm competitions, you can think of how to most efficiently handle things by just thinking about the data structure. It really is like really important, and because of that, we're going to take some time to go over them. And this is going to lead into our next section, which is going to be generic classes. So I've got the Linux virtual machine open, and I deleted the stuff from the last video, as you can see, and we've got just a basic Java template. Our make command works, and I made the file a little bit bigger, the text in the windows. Hopefully you like it. If you don't, say something in the comments. And the first thing we're going to do is we are going to import java.util. Now we went over the import statement. Basically, all of our data structure libraries live in this, so always just include this import command. And I want to fix this because the indentation is so horrible right now. Okay, that's good. I think when I copy and paste from the website, the indentation gets really messed up. And my indenting style is like way different from everyone else, so sorry to your handicap. Okay, so we've got array complex data structures. The first one we're going to do is stack, and the way you declare it is stack integer stack equals new stack integer. Now let me show you how to declare it, then we'll talk about what it is. Now, again, this is just like array list. The stack is a type, and it holds integers. This is the variable name stack. We can make this whatever we want as long as it's not a keyword. And we are initializing it to a new object. Did we go over objects? I don't remember if we did that yet. If we didn't, we're going to be doing it in the next video. We're definitely going to be talking about these brackets in the next video. But new stack integer parentheses, and that is how you declare a stack. Now, a stack is a first in, last out data structure. What that means is, let's say you have like a stack of plates. Well, when you wash dishes, the first plate you wash goes on the bottom. The next one you wash goes on top of that. The one after that goes on top of that, and you keep putting plates on top of each other. Now, when you reach for a new plate, if you just needed for dinner or something like that, the one you take is the one right on top. You don't reach for the bottom. You don't reach for a random plate. The one you take is the one that's on top. So the one that went in first is actually the one that comes out last. The one that went in last is the one that's on top, and that's the first one that you take out. That's basically a stack. And it's really good if you need to remove items. It's strongly paired with Q, but let's just see how this works. So we're going to push a few items in the stack. Should I just copy and paste it? Yeah, I can copy and paste it. No, let me just type this one out. Push 5. And you push items on top of the stack. And in this case, we're pushing integers. So let's see. 4, 3, 2, 1. Okay, that's fine. And to take a plate off, you pop the top of the stack. So we say stack.pop. So let's look through this code and see what happens. We push 5 onto the stack, the number 5. Next, we push the number 4 onto the stack. This is 5, this is 4. Then we call stack.pop, which means we take the top item off of the stack, which in this case is 4. So we take 4 off of the stack. Now our stack is just 5. Then we put 3 on top. Then we put 2 on top of that. Then we put 1 on top of that. And that's basically an integer stack. It's really that easy. It's very simple. So what we want to do is we want to show that the stack size can be stored in an integer, and you just store that by the size function. And you can print that out. I'm just going to copy and paste this because that's like a long line. So system.out.println, you know what that is. There are stack size elements in the stack. Really simple. And the way you want to move through a stack is not by a for loop, because most of the time you're removing items from the stack. You're not just going through it. Again, this is one of those reasons you should watch the other video. Why should you use a stack? Well, stacks and queues are really good at removing items from the list. You would never remove an item from an array list or a hash map or a set, because that's like an inefficient operation for them. But if you need to remove an item, stacks are like perfect for you, especially because you can put them in any order, sort of. So while stack.isEmpty, so this is the other thing we're going to look at, the isEmpty function. And this basically checks if the stack is empty. Is there an item on the stack or not? That's what this evaluates to, true or false. That returns a true or false. And we say the top item on the stack. We can find that by peeking. So this will find the stack.peek will tell you what the top item of the stack is, the top plate. It peeks on top of the plate. And you can output that. So we're going to find the top item every iteration of the loop. And we can pop the top of the stack. Stack.pop. And then we can just print a new line. System.out.println. So let's see what's happening in this loop. Is the stack empty? Well, what's that stack right now? 5, 4, but 4 got popped. 3, 2, 1. So it's 1, 2, 3, 5. That's our stack. It's going to check if the stack is empty. Is it empty? No, it's not. So it checks the top, which is 1. It prints that top, and then it pops the 1 off the top of the stack. Now our stack is 2, 3, 5. And then the while loop continues on the next iteration. Is the stack empty? It's not. So it checks the top. It's 2. It prints that out. Then it pops that 2 off. And it does the same for 3 and 5. And we expect to see that on the command line. So let's make. And perfect. There are 4 elements in the stack. 1, 2, 3, 4, 5. 1, 2, 3, 5. And that's great. So that's stacks. That's how you would use stack. Again, it's the last in first. A first and last out data structure. The next thing we're going to look at are queues. Queues are very closely related to stacks. Let me just make sure my webcam isn't blocking. Okay, no, we're good. So around here, okay. Around here. Just making sure because I made this text bigger. So queue is almost the exact same as stack. The only difference is it is a first in, first out data structure. Now we're implementing this a little differently. Make sure you pay attention. We have a queue, but the implementation is with the linked list. Now, I'm going to be straight up honest with you. This is a bit annoying. In other programming languages, it wouldn't look like this. How do I solve this? Okay, let me put like a bunch of spaces. Okay, great. So let me just remember to always keep it here. Okay, so we're saying a queue integer named q is a new linked list. This basically means that the implementation is going to be a linked list, and it's a queue that holds integers. Now, a queue is a first in, first out data structure. Think about the line in a grocery store. The first person to get online is the first person to go to the register. Anyone behind them gets in order, and they're the next people to get to the register after the people before them. It's just a line. Very simple. So you declare it using this. Just remember that. Take it for granted. This is the underlying data structure, a linked list. I guess there are other ways. I don't know. In other programming languages, they don't make you do that at all. They don't care. So our queue is going to be 4, and then we're going to put 5 in the queue. I forgot the add. And then we are going to add a 2 to the queue. And the way you would get the size, queue size, is same as stack. You just call the size method. And we can print that out. I'm just going to copy and paste that. System.out.println. And you say there are queue size elements in the queue. And then, let me scroll down a little more. And then we are going to do another, wow, the virtual machine is lagging. Wow, my keyboard is not cooperating. While queue.isEmpty is equivalent to false. And this is basically the exact same code as the stack. Now, it's going to be pretty much the exact same thing, so I'm just going to copy and paste it. Remember, stacks and queues are very closely related. The only thing that's different is the variable name is not stack, it's queue, and it's queue. And we are also going to print a new line after this. So what happens? Let's look at this code and see what happens. We've got a queue data structure that we declare, and we're adding 4 to the queue, so that 4 is in front. Then we add a 5 to the queue, 5 lines up behind 4. Then we've got a 2 that lines up in the back. Then we print the size of the queue, which is 3, and we go through the queue. The top of the queue is the 4. He came in first. So we look at that, we print it, and then we pop the 4 off of the queue. Is it pop? I don't think it's pop. It's remove. Yeah, this is a little different. Remove. So we remove the 4 from the front. He goes to the cash register and he pays for his stuff. 5 is now the front person in the line. So is the queue empty? No, we've still got 5 and 2. 5 is the top person. He goes to pay his stuff, and then 2 is alone. Then 2 is in the queue. He goes to pay, and that's how it works. Really simple. Something is wrong. There are, what is this? Expected. Oh, I forgot the semicolon. Don't forget your semicolons. Error cannot find symbol linked list. Did I mess that up? Oh, I typed linked. It's supposed to be a linked list. Sorry. If you don't know what a linked list is, it's basically the other type of data structure besides arrays, and those two are like the really basic data structures for computing programming. You've got linked lists, which are okay, since this is a data structure tutorial, arrays just hold contiguous blocks of memory so that the indexes are basically right next to each other in RAM. A linked list, the memory is basically everywhere. You've got one like block, not a block of memory, like one piece of memory here, one piece of memory here, one piece of memory here. It doesn't really matter. The reason it works is because you hold a pointer to the addresses in memory. Now, since it's not next to each other, you need to hold actual variables, but you don't need them next to each other. And because it is a linked list and the memory doesn't need to be by each other, you can basically have them wherever you want. So like imagine owning a block and then your family has to live in the block. If you have new people, then you have to relocate somewhere else because you only have so much space. That's why arrays are a bit limited, even though it's really easy because everyone's right next to each other. Linked lists are like a whole community where anyone can live anywhere. But the magic is that you have everyone's address, so you can just go to them wherever you want. It's not as quick, but you still have everyone's address. That's how linked lists work, sort of. You don't have everyone's address. One person has the address to someone else, and it's basically like a chain of that. Like, my grandma knows where my mom lives, and my mom knows where my dad lives, and my dad knows where I live, and I know where my brother lives, and it's like that sort of chain. Everyone doesn't know everyone else. Everyone just knows like one or two people at most, just their neighbors. But because of that, anyone can live anywhere. That's linked lists. So with that detour, let's make. Okay, great. 3 elements in the queue, 4, 5, 2, exactly as we expect. We're going to move on to priority queues. There are 3 more data structures. Let me just give you a heads up. There are 3 more data structures that are important. Priority queues are the next one. Priority queues are basically data structures that are like queues. They're exactly the same as queues. That's why they have the same name. But some people have a certain priority. So like when you go on an airplane, everyone can line up, but the people who enter first are the people who are like first the wheelchair people go, then the rewards members go, then military people go, then the people in the front of the plane go, like the first class people, then the people in the very back of the plane go, like aisles 15 to 25, then aisles like 5 to 15 go, like that. Everyone's in line, but the people have a certain priority that makes them go ahead of other people, and that's really useful, and we're going to see that right now. So the way you declare that is priority queue, and we're going to do a string this time instead of int. Again, the same thing as array list. We're declaring the type here, but this could be integer, double, long, whatever you need it to be. And you're going to see why in the next video on generics. So new PQ, and the implementation is going to be priority queue somehow. And let me scroll down a little so you can see a little better. And that's the priority queue. So we're going to add some strings to this. And it's basically just going to be like a bunch of letters. So let's add a bunch of letters. Wow, my computer is really lagging. I'm surprised. Sorry for this delay. I don't know why it's lagging so horribly. Looks okay to me, but... Okay, so this is how you would... No, that's not even correct. I forgot the add. pq.add. Okay, come on. Work with me. Oh, I forgot to copy the P. Come on. Come on. Watch. It's so slow. Let me increase the fan speed on my computer. I just pressed the button that increases my fan speed. Wow, somehow maybe it was a heating issue. Okay. So let's add some letters to our priority queue. We're going to add B. We're going to add Q. We're going to add S. We're going to add A. Let's add Z. Let's add X. Let's add a... Whatever, we can add XS. That's fine. Let's add a... Actually, you know what? For this example, let's not. But we'll see that in the next one. So let's add, I don't know, L. And finally, let's add a P. Now, you can see we have a bunch of items added, and remember, it's a queue, so things are going in, but there's a priority here, and the priority is automatically that the lower ones will go ahead of the bigger ones. So 1 goes in front of 2, and A goes in front of B. Now, let's print, actually, say, we'll find the priority queue size, just to show you, is pq.size, exactly the same thing. Most of the time, pq, like the dot size is how you find out the size, and we are going to print that, and I'm just going to copy that because there's no reason to print that out. Okay, so there are so many elements in the priority queue, and again, while loop is our best friend because the whole points of queues and stacks is that you can remove the items easily, and while loop's the best for that. And the reason while loop's the best for that, I should mention that, is because the size might change. Now, pq.size right now is what? 2, 4, 6, 8. There are 8 items in the queue. But that's not going to be the case when we remove one of them. When we remove one of them, the items become 7, and that messes up the loop's iteration. That's why you should use a while loop for these things. So the top is pq.peak, the top item in the list, which is not necessarily B because we have an A. Remember, this is a priority queue. It's going to be ordered, which is really the convenient thing. And we're going to print that by system.out.println. And that is top plus a space. And then we're just going to remove the front of the list. Exactly the same commands as queues. And to finish it off, we're going to create a new line, system.out.println. Actually, I messed that up. This shouldn't be a print line. This should be a print because we want it on the same line. So let's make it. And we've got a semicolon somewhere. Where did we forget the semicolon? In pq.size. Oh, that's a colon. How did I mess that up? Okay, so right here, there are 8 elements in the priority queue. And check it out. It's sorted A, B, L, P, Q, S, X, Z. Now, the reason that it's sorted is because, again, it's a priority queue. There's a certain priority. It takes a little skill to get this to work because eventually you're going to have objects and, like, maybe you have a person's first name, a person's last name, and some other data that is what gets sorted by them. Like maybe you sort by their last name, maybe you sort by their first name, maybe you sort by their income or some other number. Priority queues are great because you can have this sorted queue and it keeps one thing, it sorts it for you. That's really it. It keeps it sorted. It's so amazing. It's probably one of the best data structures. So just keep that in mind. That's why you would use a priority queue. If you need to keep something in order, use a priority queue. And you're going to need to learn more if you want to do some fancy things with it. But we'll handle that some other video. Or you could read about that yourself. Like just Google it. How to do a priority queue of class or reference. So the next data structure is set, second to last. These two are sort of linked because the underlying data structures are hash maps and red-black trees usually. And you don't need to know about that. That's like some advanced stuff. But for now, just take for granted that this is the data structure that you need to know on the top level. It's sort of like knowing, can you use a microwave? Well, yeah, you just press some buttons. Oh, do you know how the microwave works? Could you put it together if you needed to or change one of the parts? No, you couldn't do that. It's sort of like that. If you need to know how to make a microwave, then you become a microwave maker. If not, you just know how to use it, and that's good enough for your life. That's sort of the same thing here. If you ever need to know how to use the underlying data structures, you can. So we're doing sets, and it's going to be a string, and we're going to call it a set. And there are 2 types of implementations here. As I said, one is a red-black tree, and one is a hash map. Always use the tree. Pretty much always. I'm going to tell you to use a tree because the tree will preserve the order. There's really no downside to it either. So we declare it just like this, set, string set, which is a set of strings, and we create a new tree set. And so let me explain what a set is. A set is a data structure that does not keep duplicates. So let's say you had some data structure where you didn't want to, you might have a bunch of names, but the same name might come up a bunch of times. And instead of searching to see if the name is there, you just add it to the set. And if it's already there, the set's not going to add it. If it is there, if it's not there, then it will add it. So for example, we're going to have a bunch of stuff. Add it to this set, and let's see, let's add 6 things. And we're going to add the word source. We're going to add the word make. We're going to add the word Java to our set. We're going to add the string make again. We're going to add the word source again. We're going to add ice cream. And we are going to add curtains. So you can see that we have source once and it comes up again, and we have make once and it comes up again. And then we've got these other ones that only show up once. Now, as usual, we can get the set size by doing set.size, and honestly, when you're doing algorithms, you're always going to need to know the size, basically. So that's why I keep repeating this. It seems like really useless because we keep using loops, but... So let's just print this really quickly before moving on. There are 5 elements in the set, and you can see that 1, 2, 3, make was already here, so the set's not going to add it, so it doesn't. And then source shows up again, so it doesn't add it. 4, 5, just like that. Now, the way we're going to do this is by using an iterator. Now, I've got comments in the code if you go to the website. Let me zoom a little. I've got comments that explain what this is, so go ahead and read that. But for now, you don't want to use a while loop here because you don't really ever want to remove an item from the set. If you're removing an item from the set, you're probably doing it wrong. Probably. I mean, there is a way to remove it, but just don't remove it. I wouldn't remove it. So we are going to iterate through a different way. Now, before when we used for loops, we did it with, you saw int I equals 0. If I is less than some number, then I++. That's the real way you use for loops. But in Java and C#, there are these things called iterators where basically you have this set and Java is going to take care of this for you. There's actually a way to do this, which is really nice. And the class handles being able to iterate through the items instead of you needing to do it yourself. Because otherwise you would need an iterator which goes through the pointers, and that's a lot of work. Basically, we're saying, okay, for each set item, for each string in the set, we're going to name that string set item, and we're just going to go through each one. That's the way it works. Really easy. And we're just going to print them. So I'm just going to copy this one line. And I'm going to copy the other one to make a new white space. So what this line does is it prints a space, then the set item, which is going to be a string like curtains. Then it prints this space in a bar. So let's make this. And you can see there are 5 elements in the set: curtains, ice cream, Java, make, and source. And again, we had some duplicates, but those didn't get added because sets don't add duplicates. Now, one thing I will mention, you don't need to use a tree set. The other word you can use, I believe, is hash set. But if you use hash set, it still works, but order is not preserved. You can see that ice cream is first, then Java, then source, then curtains, then make. Which is really weird, right? Because that's not even the order that we added them in. Curtains, then ice cream, then source, then make, then Java would make sense. Or maybe source, then make, then whatever. It doesn't even go in the order that we add them. Not to mention that it's not alphabetical. This one was alphabetical, right? C, I, J, M, S. And that's because hash sets are basically hash maps, which means you take an item, and you'll see this in the hash section in the next section, but you take an item, you do a, how would you say this? I forgot the word. Oh no, I forgot the word. You do an encryption on it. It's not encryption. You do a hash function on it, is what it is. Hash function on it. And it converts it to something that really shouldn't be copied. It's like uncopyable. It's like a one-to-one function, basically. I'm not explaining it well, but again, that's like an underlying data structure. So always use tree set instead so that order will be preserved. Makes a lot more sense. So this is our final complex data structure, and this is a hash map. And my computer is lagging. And what we are going to do is we are going to, if this page will cooperate, it'll show me, we're going to create a hash map. Now, a hash map is known as also a dictionary. What it does is it maps one item to another item. It's a key value pair based data structure. So, for example, a dictionary is what we would use in real life as an example. For a dictionary, you have this word, which is a string, and it maps to a definition. So if you look up the word, I don't know, tree in the dictionary, that's the key, and then somewhere in the dictionary there is that definition for tree. That's a key value pair. And this is really powerful because the lookup time is constant, basically, because the underlying data structure is a hash table, hash map, and it's really quick if you need to look things up. We didn't go over times, but it's an order one lookup time, which is actually amazing, as opposed to other data structures where an array, like think about an array. How fast does it take to find an item in an array? If you know the index, you know exactly where to look for it. What if you don't know the index? What if you have to search through the whole array? Well, then you might actually have to search through the whole array, which is not good in good speeds. But hash maps are really good because you can look up the item as long as you know it in constant time, order one time. And that doesn't make sense because we didn't talk about big O notation or time complexity, but this is how you use a hash map. Just look at this. You use hash map, and we're going to map a string to an integer. And if my computer would cooperate, this would be great. So we're going to say that equals new hash map, and it's a hash map that maps strings to integers. And we are going to initialize it. And the way we add something is we say map.put. And we're going to say that our hash map is going to give scores. And we're going to give source make 100. That guy's pretty cool, right? We're going to give him 100. And we're going to put vegetables as a map, which basically means, again, key value pair. The word vegetables, the string vegetables, is mapped to an integer that can be looked up in constant time. And vegetables aren't good, so we give them a 0. And finally, we're going to map just one more thing. We're going to map chocolate. And we give that a score of 500. Wow, I meant to say 50, but 500 works well too. So to get a value, you can print it like this. And we're going to go over this line. And this probably is not able to be seen on your screen, so let me scroll down. Come on, okay. So source make scores a value of, and you do map.get source make. Now this is, again, constant time, so it's really efficient. If you know the string you need to look up, then it's great to look up the integer, as opposed to other data structures. Like, think about it. If you had to say, okay, this string is associated with some number, how would you do it? Would you have like two arrays, one array for the string and one array for the integer? That's not efficient at all. The way you do it is a hash map. Think about it like that. And to go through all the values, you would say for map.entry. Now this is a little weird, but just take it from me. This is what you should do. Map.entry set. So remember before when we did the set, how we said we could go through each object? Well, each object in this case is a map entry, which is a string and an integer, and the variable name for that is going to be pair, and it's going to go through the maps entry set. So what we're going through is the maps entry set, which is the entire map, and each thing that we're going through is a string and integer that is a pair. So we're going to name it pair. You can name this whatever you want, but I'm going to name it pair. And we've got the key. It's a key value pair, right? So pair.getKey. I'm going to store this into local variables just for easiness. I like to do that all the time. It's less efficient, to be honest with you, but it makes readability a lot better. So the key value pair is going to be pair.getKey and pair.getValue. And you know, one's a string, one's an int. And we are going to print that. So we're going to go through each item in our map. And the key is the key, which is this variable key, which is a string, which we get by getting the pair.getKey method. And our value /t is going to tab this for us. And the value is the value variable. So let's make this. And you can see we go through each item in the map, and it is going to tell us the value. So source make is a 100, vegetables is 0, chocolate, which I misspelled, I didn't even notice, is a 500. So that's key value pairs using hash maps. So those are the 5 data structures that you really need to be good programmer. So that's how you implement them in Java. Again, this is a little cheat sheet. I don't want to spend too much more time because we spent a lot of time on this video. But data structures are really important. They help you think in a way to solve problems that you wouldn't normally be able to do. And having someone tell you how to use this is really important. So again, the best way to go through this stuff is to practice it. And then when you actually need to apply it, you remember, oh, a queue would be good for this, but I don't know how to implement it. So you just Google it. Queue for Java queue strings or something like that, if that's what you need to do in the future. I just showed you the basic stuff. So that's how you use complex data structures in Java. In the next video, we're going to be going over generic classes and methods. And what that's going to do is, you see these things right here when you declare the class, we're going to learn why that happens in the next video. So I'm SourceMake. This is the Java series. You learned about complex data structures in Java. Thanks for watching.